Thanks, Neeraj. Hi, everyone. Today we will be presenting the Vertica capability about predictive analytics and how we use predictive analytics in Vertica. And before I start, I just want to introduce that who are the speakers. So I'm Ravi Gupta. I'm pre-sales head for the India and SAARC region. I take care about Vertica solution architecting and technology piece of Vertica. And I have along with me Kaito from Japan. He is also Vertica pre-sales. And he is actually expert in machine learning and predictive analytics, and he has done quite a few projects in his region, especially for machine learning. So the agenda of today's discussion is that I will showcase few things about Vertica in the beginning itself, because I assume that there are few people who are new to Vertica, there are few people who understand Vertica well, but I will go through quickly the few core features about Vertica, and then what is our focus in Vertica, and then I will cover a few use cases about Vertica and machine learning, how they have helped customer. Then I will also cover a little bit about what is basic machine learning, a few success stories, and how machine learning looks in Vertica. So we'll cover all of these points. And then we will also showcase you a demo about machine learning that we have prepared. So Vertica is, as you know, that Vertica is one of the early column store databases, and Vertica is especially designed for fast performance or high performance, and it is very working very closely like an open architecture. The way it works is pure SQL platform, and at a core it is actually a SQL database, but the kind of working environment within Vertica, it's like you are working in an open source environment, and the architecture is quite open, and it works and connects with so many ETL and BI tools available in the market, and it is very easily integrable with all of them. Our focus was always on high performance as we came in the market at around 2005. But as time passes and market demands, we keep on adding new features. The core feature about Vertica is especially that it is a very easy interface because it is purely SQL based. Everything in Vertica is SQL. It is especially designed for OLAP workload, not designed for OLTP. And it is also having inbuilt high availability within the platform. That means it runs on an MPP platform, multiple nodes runs all together, and if some nodes went down, still remaining nodes are up and running. The internal architecture of Vertica is like it stores data in columnar format, and it does a heavy compression. One of the key thing in Vertica is that when DBA put a lot of effort to optimize and understand how to optimize the queries or how to improve the performance, Vertica comes up with the inbuilt utility which understand your query patterns, understand sample data, and then it also gives an option like DBD, which we call as a database designer, which helps DBAs to tune the database accordingly what customer queries are coming. It is also designed for continuous load and query. That means you can load and query data at the same time. As I said, our focus was always on keeping performance high, and that is why Vertica is known by different customers, because there is always high performance. But other than performance, we are also making ourselves flexible. That means we are also actually making ourselves deployable. You can deploy anywhere. You can deploy it on any cloud. That means on Amazon, or Azure. And the working conditions in Vertica is like you work on an open source, but at the same time keeping demand in the market, we have added feature like machine learning within Vertica platform, and that is what we are trying to showcase here. I will little bit showcase about the architecture of Vertica, that how it fits in the ecosystem. In this picture, you see that the middle one is whole Vertica platform with lot of capabilities inbuilt, which is having geospatial capability, time series, event series functions inbuilt, and it also has click stream and a lot of analytical functions inbuilt. You can use user-defined programs like R, Java, C++, or Python to integrate with Vertica. On the left-hand side, you will see that ETL and data ingestion tools like Kafka, Spark, or ETL tool like Informatica at Unity, all this loads data from the left-hand side. They can read right from Vertica. On the right-hand side, we have a lot of visualization tool like TableView or Click or Cognos or MicroStrategy. All tool can read the data from Vertica. Vertica can store its data on normal ext4 file system, or if you have your own predefined file system like something like Hadoop, Vertica can also read right from Hadoop. So Vertica has a flexible architecture. It can by default read right from the ext4 file system, but it can also read from there. It gives a lot of advantage for user to flexibly deploy it anywhere, either in cloud or on top of Hadoop or without Hadoop also. I'm also trying to showcase you that how customers' journey is along with data. I mean, how customers see that where are they in the data and analytics field, and the first thing when we meet customer, we try to understand where they are. Is generally in the early days, people start creating reports out of a database. They assume that there is a data and there are some static report on which they do drill up and drill down and see the reports. And as the time passes and the requirement increases and they also little bit go mature, they start creating dashboards on top of that report. They can see that what is happening in the real time, how their billing system or how their customer responses are coming. They can see in a dashboard how they are coming. But what is the next step is that they can, based upon their historical data, they can see the pattern and they can also do a little bit of prediction that this is going to happen. So this is the third stage where customers try to read data and do some prediction work. They can see the trend, they can do the prediction out of that data. But what is the final stage is that the prediction is so much dynamic because the kind of data sources or the information coming from different departments for the customer. As the business has a lot of departments, the data keeps on coming from different sources and they keep on changing. So our predictive models or predictions should also keep on varying. For example, from one festival and there is no festival. So in the festival, the demand is high. That means our predictive models or prediction should be accordingly to time, they should also change and accordingly suggest us. So the fourth stage is that the prediction which we are doing is also dynamic. That means the prediction is so much advanced that it keep on learning from the customer behavior, and it also keep on giving you advice which is keep on changing as per the data is coming. I would like to showcase you a little bit about what is machine learning. So machine learning is it was actually part of artificial intelligence. It enables computer to get data or read data from a different sequence of events, and it learns from events. And events are captured from different devices or machines in the form of data. So machine learning are certain set of algorithms which keeps on reading data from different sources, and they keep on capturing the sequence of event, and they keep on educating themselves or learning out of that data pattern. And the machine learning at the end help us to classify the data into different groups, or classify what is possible or not possible, and then predict out of that. And there are certain kind of learning techniques available, like supervised learning and unsupervised learning. So supervised learnings are like when you know what is going to happen. If this is red or this is yellow, you know in advance. But in unsupervised, you don't know. You actually learn from the events itself that what is going to happen. A few of the example I would like to give you that how machine learning helps actually end customers is, for example, these are very common examples, like you want to predict the prices of a house based upon certain data points you already have, and based upon different data sets, the machine learns out of that, and then it gives you price for a house for a particular reason based upon your number of square feet, or at what location you want. Similarly, machine learning have techniques like Neubase, which helps to filtering the emails and spam, that whether there is any spam or not, so filter those emails and those will not come to you. Similarly, machine learning can also help you that for an ad industry, whether they are giving an ad through a mobile, and whether people will click on that ad and download a new app or not. So machine learning's help from customer behavior and gives you that what kind of ads should be given to what customers, and accordingly they will click on that, or whether they will download a app or not. And similarly, machine learning can also help you to predict whether customers are coming into your website or store, whether they will buy or not, mostly based upon their historical patterns. Machine learning also has techniques like neural networks, which helps to even improve your thought. Like you create your model, and they improve those models to work more accurately. Machine learning can even help to set up a new, let's say, pizza shop. You are trying to set up that. It can help that where are the people, what is their location, what is the mean location, and then it creates a lot of clusters out of that people locations, and then it found out where is the location which is most ideal for a city, and where we should put a new shop. Actually, machine learning can help you to decide that. You can do by yourself as well, but machine learning has some algorithms which can automatically read data and then give you those conclusions faster rather than you draw by yourself. I would like to show you a few success stories what Vertica has. So one of the customer named Cardlytics. Cardlytics is a customer who has been using data for all card transactions. Basically, Cardlytics customers are banks and credit card companies. So they get data from banks that how people are buying or how people are using their cards, and then they do the prediction for banks actually. So bank use Cardlytics as a service, but Cardlytics at the background do a lot of data churning. They do a lot of data analysis, and earlier they were using platform like Spark, and they were taking a lot of time to categorize the categorize their customers or doing customer segmentation. Earlier, they were doing a lot of, they were spending time to segment the customer. And after using Vertica as a platform, they found that the same time of customer segmentation has reduced from 24 minutes to 3 minutes for 15 million of customers. And segmentation have their own, techniques in the background. There is one more customer called Ecobee. This customer is actually selling devices which are used or installed in the home. It controls the temperature of the home. So they have a sensor which keep on collecting the temperature of different rooms or locations within a home or outside at home locations, and they capture data into a single place, and then they predict that whether this machine can fail, or they also predict that what will be the temperature or what are the conditions. Accordingly, they predict few things out of that, and they use Vertica as a prediction technique, because earlier they were using Python as a program. But as you know, in the current time, that the expectation is that we want to do things very quickly. Even all the predictions we want to do quickly in the real time. And when we want to do quickly in the real time, we need engines in the background which can quickly give you responses about those models and how they predict things faster. There's a security company called Fidelis. So they are in the cyber security business, and they they collect a lot of alerts, and they want to predict things very fast. And earlier they were using Spark as a platform to do that, but now they are actually getting faster performance out of that, out of this Vertica as a platform. So this is a cyber security company who use Vertica for machine learning purpose, and they put all the alerts into Vertica and then predict what is the possibility of a security threat at a particular place or not. One of the recent example what we have done is in Auckland, New Zealand. So their public transportation system, they are also using Vertica as a predictive analytics tool, and the purpose and the use case was that they want to predict that that how many riders will be there on a particular stop, how many people will be there. So they had, and ultimately the purpose is that they want to maintain their bus routing system as per the riders are there on those specific areas. So they want to know in advance that how many buses we should have at that time, or what should be frequency. If they can predict that demand will be more on those days, and if there is a festival or there is a weekend or not, and a lot of parameters are there. And based upon different parameters, actually, we worked out that we have actually studied their data, and we found out different parameters, and we loaded all this data into our platform, and we created certain models to predict at least 2 days in advance that how many riders will be there on a particular stop. And with the help of number of riders predicted, the bus routing mechanism or the bus routing algorithms also put additional buses or delay those buses, or increase or decrease the frequency of the buses according to that, because they want to optimize on that particular area. And in Vertica, it is very easy. I'm trying to showcase you is that most of the thing what you see here is mostly is all what you see the SQL based. SQL based means everything in Vertica is SQL. Even if you analyze the data, you prepare some data, you want to test some data, you want to create models, everything is SQL. So we got some their trips data, and then we try to create different combinations or groups within that data, and then we created regression models to find out what will be the number of riders on particular days. And our results are actually as much as like 80% are accurate what we have seen there. And as you know that in machine learning, the models keep on improving with time. So as time will pass and the real-time data will come day to day, the models will also get more improved, and we will get more accurate results. As of now, for 80% cases, we are getting within +1 minus rider, or what we actually predict and what we actually get. I would like to now highlight that why Vertica machine learning as compared to others. So in the past, whenever people were trying to get into these machine learning applications, or they were trying to develop something, for machine learning, what was happening is they have a data platform or they have a database, but in order to do all this prediction works, they need to have a separate machine, or sometimes they need to have a separate software. Even in open source R, they need to set up something in one machine to do that. Okay, and they need to do some sampling out of that data, because when you want to create a model, you would like to do some sampling out of that data. And when you do some sampling, you need to have, sometimes your result set or the data which you get out of that system itself is very high or huge, you can say. Even creating those samples itself take a lot of time. The other thing is that if you start developing model out of that data, let's say you get 1 billion record and take 100 million or 50 million as a sample, and you start getting model of that your model performance itself is very slow, because that the techniques which are available earlier, if you try to predict, it will take some time, hours or maybe 3 to 4 hours to develop a model and then test that model, and even to check with the real-time data, it takes a lot of time. What we are trying to make, simplifying all these things, and you don't require a lot of machines or other hardware. You can deploy within Vertica, and the model development and performance of the model will be fast. And that is why what is Vertica's unique proposition over here is that we would not require a separate machine or hardware. You can run Vertica machine learning within Vertica platform. You don't require additional RAM or any additional hardware or node. The other thing is that in Vertica, since Vertica is a MPP platform, the performance of models, creation of those models, validation of those models, and running those models, that is very high with Vertica. Because Vertica has a in-memory processing capability also whenever required, and based upon the data, it can do MPP. So that is very, very useful, because if your model development and testing of those models and deployment is fast, actually it helps business to go and take faster decision. Other unique thing with Vertica is that if you use any other tool like Spark or any other proprietary tool, there is always an issue in terms of concurrency. What Vertica offers is that even 5 or 10 developer can create their own model all concurrently at the same time, and they can deploy also. If you go into Spark or any other platform, and if you try to create, let's say you give that 5 developer, they create their own model and they try to test that, you will definitely found that the moment you try to test multiple models, the system performance will be slow. But in our case, Vertica is already known for high performance and high concurrent user acceptable. Vertica helps here also. The fourth thing, which is very good for all developers, basically, that Vertica is a SQL based platform. Even machine learning is through SQL. Everything in Vertica for machine learning will come as a SQL. You don't need to require any R, Python, or any other programming language until and unless it is your own proprietary code. But if you want to develop anything in Vertica, it will be through SQL only. So the adoption of platform is on both on all the four things, and that is why people have adopted that, and they found that speed they are getting is out of MPP, and that the easiness of use that product and develop models is quite fast in Vertica, and they don't need to learn a lot of different programming languages. I would also like to showcase that machine learning algorithms which are available in Vertica, we have actually in three categories. One is that regression algorithms, which includes linear regression and SVM regression. We have classification algorithms, which include logistic regression and naive Bayes and random forest. And we have clustering algorithms, which is like k-means. We have also done some competitive study, again, an open source platform like Spark, where people think that it is a quite fast platform. And if you see the result that we have done it for 4 different algorithms here, and every testing has been done against a data set which has roughly 100 columns, and the volume of data roughly in the main range of you can see that it starts from 10 million to 100 million and the billion record. And you can see that the moment you go with high number of volume, how other platform, which is in purple, their execution time will go very high. As compared to Vertica, the execution time is not going high even if you go 100 times, 10 times, and again 10 times of from 100 millions to a billion size of data. How does machine learning looks like in Vertica? As I said in the past, everything in Vertica will be an SQL. Even your sample data, you will be loading into your own data table first of all. So for example, you can create a table and you can load that data into a table using copy commands in Vertica. So what we are trying to showcase is that you first create a table which is having all the variables or number of parameters which you are getting as a source file. You create a table and then you load that data into that table, and then you create your test data. So what is happening, let's say you get 1 million record. So in order to create a model, you actually you break the data into two pieces. One is that uh, a test data and a train data. So train data is actually a training data on the basis of which you will create a model and train that model. So model will read that training data and create that. But the testing data is something where you will actually learn your model with the help of that test. So you will see that whether the model is accurate, whether it is giving correct results or not. So in order to test that model, we call as a test data, and test data is roughly generally in the range of 20 to 30% out of the whole data, and you take 75% to 80% data as a training data. So you create a model, and then you after creating the model, you do some prediction using the test data, and you then check that whether that model is correct or not. So you will see that in Vertica everything looks like a SQL, and with the help of SQL you can draw the conclusion also. And I would also like to showcase you that if you would like to write a similar code in programming languages like Spark, you would maybe end up with writing a lot of code. Uh, for example, you write in Spark, you include libraries, you write number of parameters, etc. And then you load data, and then you create a lot of local variables. Then you do some extraction of some columns out of that, and then you also do some data conversion within Spark to create a model. You split the data into two pieces, and then you create a model and then apply the different techniques to improve that model, and then you run that model. What I'm trying to showcase here is that if you compare Vertica's machine learning and the coding required in Vertica is quite less as compared to any other popular platform which is available. The number of lines as a coding you would require is quite less as compared to any other uh, tools available. We want to make things simple and faster. As I said, um, Vertica supports actually entirely all the stuff which you use in the machine learning. It includes data preparation, modeling, evaluation, and deployment. Data preparation itself is a little bit, a tricky task in the terms, because you need to understand how is data, and there are different ways to identify your data, the data quality, what type of data, whether it is having basically high cardinality data, what low cardinality data, what is the mean, median. So as a data scientist, you would like to do a lot of things with the data, and then you decide which are the parameters which are affecting more. Sometimes you do more data science first, the data preparation itself. Data preparation also includes cleaning of the data and aggregation of the data. You put a lot of effort in that that cycle. And Vertica helps because everything in Vertica is created as tables, so you can keep on sometimes creating temporary tables or views on top of a single data set. And we also provide a lot of functions within Vertica which helps you to normalize the data and take the sample of the data. I will actually show you down the line. um, we have all the modeling capability. Evaluation functions are also inbuilt in Vertica. I will go through one by one. As I said, the data preparation and normalization is a very important step, because what you get sometimes data does not have all the qualifiers or all the columns available in the data set. You need to normalize the data. You need to find out which data sets sometimes have a lot of null values. So how to ignore them or how to fill them. For every data validation and understanding the pattern of data, there are different methods available. I mean, if you understand data science, there are methods available. What we are trying to showcase here is that whatever data preparation things like normalization or outline detection or sampling, or doing imbalanced data processing or missing values or handling all these things, Vertica provides inbuilt functions. For example, these are the functions in Vertica. I mean, you say create or select, apply, normalize, and you pass the table name and column name. So it will give you all the things: apply, normalize, balance, detect, outliner. So these are all functions in Vertica which are inbuilt. Okay. Similar, and the next thing is that after data preparation, we support as of today is 6 different modeling techniques. One of the technique is linear regression. Linear regression is a technique to predict some values, for example, forecasting sales and revenues or demand forecasting. The second technique we have is a logistic regression, which is a part of a binary classification. You would like to see that whether somebody will choose a product or not, something like that. And K means is algorithm available in Vertica for clustering. You want to do customer segmentations because you want to give different offers to them, that which offer will go to whom and which offer will not go to whom. So you want to create multiple customer segments and then accordingly give them offer based upon the segmentation. We also provide algorithms like NeoBase, which is an enhancement of you can say classification, and it helps you to do more drug discovery kind of thing. We also have enhanced things about SVM, which is support vector machines, and it is also part of a prediction things. We also have a random forest algorithms available in Vertica, which is a multi-class classification things. So there are 6 algorithms as of available in Vertica to help you predict and classifying your data set based upon different variables. And I would also like to show you that everything in Vertica, if you see that, is available as a function. So you just need to call these functions: linear regression, logistic regression, random forest, SVM classifier. Whatever function you will call along with certain parameters, and parameters are generally the source name or the column on which you want to predict the thing. Based upon your uh, table name and column name, it will predict, it will create model and predict the things for you. As I said, after creation of those models, as I said, there are 6 techniques. As I shown you, there are different techniques to evaluate whether your model is accurate or not, whether it is giving you correct data or not. There are different techniques also to evaluate whether the model is good or not. And we have 6 different techniques also. For example, these 3 techniques, which are like confusion matrix and ROC and lift table, all these techniques are helping you to check whether the model is accurate or not. For example, these things are useful. These 3 techniques are useful for classification models. We also have R squared, mean squared error, and error rate methods as a model evaluation. These are good for your linear regression things where you predict a lot of things. So these techniques are available in Vertica as a function. You can use these functions along with the model name. So after you create a model in Vertica, you use these techniques to evaluate whether models are accurate or not. That helps you to understand whether your models are performing well or not within the inbuilt functions. As I was saying, that everything is a function, so you call these functions and you pass the model name in the function, and it will show you everything out of that model, whether the model is performing well or not, what are the different factors of the model, and how they're performing. Vertica also helps you to give ability to do model management. That means if you create or user creates so many models, you can check that there are hundreds of models created. You can summarize the model, you can rename the model, you can drop the model whenever required. So not only the prediction capability as a standalone feature, you can create so many models and models can keep on improving with time. You can also do the model management within Vertica. Vertica is not just coming with these new things, as I said, the machine learning capability. Vertica also comes with inbuilt so many analytical things inbuilt. For example, you see a lot of things here, a lot of functionalities are here. In the middle one is a measure and prepare, where we have geospatial capability and click stream and different capabilities inbuilt in Vertica. These all things all together helps actually to prepare your data well or understand your data well, and then you apply all the modeling and other techniques which you see in the right hand side. In the left hand side, the capture and enriches is these are the methods which helps you to load data from different sources. Either you can read data from a format which is a JSON format, or these are external tables, or the data if this is in the format of Avro or different formats. If the data is in cloud in S3 or those locations, Vertica can read directly from there. Vertica can read data from streaming and through Kafka also. And if you have data in Hadoop, in ORC, Parquet, and those formats, Vertica can read from there also. So what I'm trying to summarize here is that we have a capability to read from different sources. We have a capability to take those data, understand them, and prepare them very well in Vertica because of the inbuilt functions, and then we can create models and deploy them within Vertica. These all together helps to complete the predictive analytics capability in Vertica, and I would like to showcase a little bit a demo here, and I will actually I will run a slide here, and I will ask my colleague Kaito from who will actually describe you a little bit about that that demo which we are going to showcase you, and we will also run a demo after that. So Kaito, over to you.
Yeah. Thank you for giving the mic to me. So I'm Kaito, working in Tokyo. So I'm working for Vertica business for several years, especially for telecom industry and the retail industry and manufacturing industry. Now the AI and machine learning are very hot area in Japan. So they would like to do more advanced things at the Vertica platform. So today I would like to introduce what this demonstration doing behind the scene with our first-hand experience. So this demonstration is very close to real-world experience. So you can apply this technique to your surrounding business environment as well. So such as server monitoring or manufacturing machine monitoring or house home appliance monitoring. That kind of things you can apply with our Vertica Advanced Analytics. So firstly, I would like to introduce a basic our procedure to achieve the machine learning approach. So I use this slide because this one was used for the Auckland Transport project. So we usually use this kind of technique to achieve the machine learning approach. The firstly, we understand business requirement. This is very important because sometimes there is big gap with management people and technical people. So understanding business. Then next one is data understanding. Then we have to think about how we can convert the data into Vertica architecture. So that is the third step. So please look at the right side of the picture. So this is the PDC cycle. And then also some process is a recursive process. We have to do back and forth to find the best model, best procedure to improve the accuracy, to find the insight. So this is a very basic one. Then also after data preparation, we can try to find the modeling with machine learning technique and another advanced technique as well. The Vertica has a wide range of the function. So our technique can support, our technology can support to you to find out the best way to process the data. Then after that, machine learning techniques, we usually use the evaluation process. So we have to check the answer. So we provide that function with a very simple, comprehensive SQL technique. Then after that, this model and technique apply to production system. So this demo is used this procedure. So please go to next slide. So after my explanation, Ravi going to do demonstration with the live demo. So before going to that demo, I would like to explain what is a cooling tower. Cooling tower is a cooling system to the temperature temperature down. So usually factory and the building has several cooling tower on top of the roof. Then this is a very important equipment for the industry. So this company, the cooling tower provider, would like to monitor the cooling tower, which cooling tower is going to be failure. So that is a very important monitoring to reduce the maintenance cost. So this demo is achieving that requirement. So please go to next slide. So during the machine learning PDC process, we need build up some architecture. So in this demo, initially we load the data into Vertica. So left side, we generate the data. So this data is very close to real world data, but we manipulated data a little bit for demo purpose. Then we, first step, number one, we load the data into Vertica. We can provide very simple copy command, then the data at the Vertica. Then once we got the data in the Vertica, we can create a model with some data cleansing process or modeling process with high speed, because Vertica has a very high-speed architecture, so you can recursively test a try and error, cut and try at the Vertica environment. This is one of the beautiful points. The third step, once you find out the machine learning model, you can apply that model to predict the value. So this case is this predictive model applied to find the failure, a possibility of the failure. So later I will show you the query to find the equipment going to be failed. Then finally, step 4, visualize the result as the PHP-based UI. Maybe if you are using Tableau or another BI, you can apply to this query as your favorite BI as well. So please go to next slide. Ravi, could you? Yeah, thank you. Then we would like to demonstrate the very close to real-world business environment. So we created the sensor generate simulation program to generate the sensor data. So after loaded the initial data, we continuously load the data using the that program. Then the data goes to Vertica, very similar to initial load phase. Then after that, step 3, machine learning technique iterates the machine learning modeling calculation again to improve the accuracy of the model. So this is one of the important points to success the machine learning process. Then that new model, updated model, apply to predictive query to find out the possibility of the failure of the cooling tower equipment. Then that data goes to BI2. Yeah, please go to next slide. So this is the dashboard. Later, Ravi is going to explain this one. So there is some function. So basic dashboard and time series chart, and also mapping using Vertica geospatial analytics. So this is a very interesting dashboard to find out what Vertica can do. Yeah, please go to next slide, please. So firstly, at the data preparation phase, I introduced one of the basic SQL method. So if you go to the free Vertica test drive, you can find out more detail of this query. But I will just introduce one query. So firstly, before doing the machine learning process, create a table as a data preparation. Then next one is load the data using the copy. So Vertica can load the data with high speed because we support the bulk load. So very fast, you can load the data with high speed using this one. Yeah, please go to next slide. Then after load the data, we try to find out the best model using this machine learning function. We have several machine learning functions, so you should test, evaluate several machine learning functions to find the best model. Maybe the logistic regression is the best algorithm. Maybe support vector machine is the best model for you. So this is a very recursive process. So you have to spend the time to find the best one. Then you can use the evaluation function as well. So this one is very important to find the best model. Yeah, please go to next. So I would like to break down more detail of logistic regression. This cooling tower demo, we find out the logistic regression is the best model to identify the possibility of failure cooling tower. So we use logistic regression after doing some iterative process. Then this logistic regression query has several parameters. So first section, you need to define the model name. This becomes kind of a label. Then next one is the input table. So you can read the data from this table. Then this data processed by logistic regression process. So then the next third parameter is the response. So we would like to predict the asset status using the last section: temperature, power factor, air flow, pressure, vibration. This parameter we would like to use to predict the asset status. So with logistic regression. So you can define that kind of a parameter after iterative process. Yeah, please go to next slide. Then after run the logistic regression function model is created, then you can display the summary of the machine learning model. So statistician would like to know what kind of a model was created for that model. So this summary function is helpful to understand. Yeah, please go to next. Then next one is we already find out the model. So we are already coming to development phase, very close to this one is the last phase of the PDC cycle. So we can use the model to predict the failure or possibility of failure for cooling tower. So the first section specify the column for use the predictive analysis. Then the second highlighted one sets the model name, which previously I named the model. Then our last one, we can use the output format. So could be the probability is a good one, because if you type another parameter, just reply back the 1 or 0. So 1 or 0 meaning is the failure possibility is high, the answer become 1. If the failure possibility low, just reply the 0. But probability, you can get the percentage of the probability, so it could be easy to handle the result. So it could be a good one. Yeah. Okay. Please go to next one. Then, so this one is final. Final query. So that predictive logistic regression function, you can embed it into a select query. So this time is this demonstration recursively we use insert select statement to after calculating the failure possibility of the failure using logistic regression model, then the data goes to new table. So we already defined the new table for the result of the predictive analysis. Then this query, the result go to that table. Then that table is used for BI tool. So please go to next. So this is the one example. So after this presentation, the Ravi going to explain the demo page one by one. So this one is one of easy way easy dashboard to understand. So this dashboard explains how many cooling tower running and then with status. The status explains 3 levels: running okay, at risk. So at risk meaning is the possibility of the failure is 70% or more. So down is completely down. So that kind of dashboard we can see. Then please go to next slide. So behind the scene, this query is running. So if you read the white paper, quick guide, once you access to Vertica trial test drive, you can download the PDF file for the quick demo, quick guide. So you can find several query for the BI tool. So this is a query for the previous dashboard. So that kind of sample query you can see if you read the PDF file. Yeah, right. Please go to next. Yeah, finish. So please.
Yeah, I think we are done now. We will we'll try to show you the demo, which is actually available for you also, for all of you. If you go to Vertica.com, we have actually put a link called Try Vertica. If you click on that link, actually it will open up you a link to go here as a test drive Vertica for AWS. And if you click on test drive in AWS, you will reach into this page where you may be required to give your basic information or like username, password, and mail ID. After you do that, you will click try it for free. So it will actually launch a drive, which drive you can, it will launch a drive which will work for 4 hours. So I launched a drive around a couple of hours back, and this is still running. And I will show you right now, this demo is running on AWS and there is no data as of now. And actually I will show you some steps here so that in front of you, 1 second, I'm trying to run demo for you. So I'm trying to log into the AWS machine from my local VM. Okay, so I will go into test drive and then we'll go into this directory. Whatever steps I'm doing, by the way, is also mentioned in the, if you go in the test drive page, there is a document, test drive manual. So if you read this document, it will open a PDF file. So all the steps which I'm doing are already here. It will be good if you want to try by yourself. So this directory has all the SQL queries available. And first of all, I will create all the tables, or basically schema, you can say all the tables which will have create table definition. It will create all the tables. And then we will also load initial data. So initial data means these, this query, this file has all the loading script which says copy from file, and it will load data into 6 different tables. And most of the tables which are quickly loaded, or you can say dimension kind of table, which is location or machine ID or the sensor data. And the larger data set which you see, more than 1 million records roughly loaded here, are basically our sample data. So if we want to see what data has been loaded, we also have a row count check, which will show you that which table has how many records, initial readings, risk score, that means we want to predict the risk, but risk scoring has not been done, which is 0. These are the number of assets we have. asset locations, where the locations are there, addresses and their location names are there. So data has been loaded, but as of now, there is no prediction done. Now we would like to create uh, a I will first show you what is there in this file. This is a create model logistic regression for risk score. This is actually this file is having a query like create select logistics reg. So it will create this model and it will predict the value of 0 or 1, and based upon these 5 parameters as Kaito was explaining. So I will create this model and you can see that how quickly we are able to create this model. So we will just say is equal minus f. Okay, so now we have created a model here, and if you go here and after creating the model, let me see what is happening here. I would like to refresh the dashboard. This was showing. So based upon the initial model creation and the data which we have loaded as static data, it has done its own analysis in the beginning, and you see that there are 10,000 towers and this much is running okay, this much is at risk, and that much down. If you click on the risk tower, you can even see that at what customer location how many cooling towers are at risk. If you click here, you can even see each component wise data, which will be shown here as a graph. So what I am trying to show here is that in the dashboard, it has 10,000 towers. It found that this much is running, this much is at risk, and this much is down. The next step of the demo is that we would like to simulate. Simulate means, let's say you first had reading for that, but in actually production environment, the sensor data will keep on coming after every 10 minutes or 20 minutes. Now, how our model will keep on improving and changing as per the real-time data, we are trying to simulate the same thing here. In order to simulate, we have certain parameters that how many towers you want to launch, for how many towers you want to take the data. The next sample data is also being available within the VM, which I was showing here. It is also having some sample data for the next sets. And based upon the next set, I will start a simulation program which will run for certain duration. I mean, we can control that also. So if we say start, actually it will start truncating all the data in the beginning and start loading the data which is coming from the real time. So the real time, what we have done is we have created certain set of data sets in the background. So the data will keep on loading. Every data set will keep on loading, and it will keep on changing the model behavior. And then model behavior will keep on updating itself. And after certain duration, we will see that it is finding that whether some towers are at risk or something is going to down. So we will wait here for some time, let the reading reaches to more than 1 million, and then we will see whether it is able to predict some failure or some towers at risk or not. So we can see that the whole simulation which we have done is based upon certain I think Perl based and PHP based program which are running, but the data sample we have created. It is trying to simulate a real production environment where data will keep on coming every 5 minutes or 10 minutes. So you could actually change everything from the parameter which I was showing here. But as of now, the simulator is running, and whenever we want, we will stop that simulator, and then what it will show is at the end is it will compare that what was our initial model and what is our current model. Let us see. Let's keep on reading the data. Let us see what it shows. We can even go to your tower map, and you can go to a location and you can click on a certain tower. And everything is running on a single VM, which is on AWS, a single machine. You can, if you know that, you can go to any location and you can see the data for that location. What I'm trying to show you is that from map you can reach to that location and look that. Let me see what is happening at towers, which is showing as a down. You can go there and see which towers are down. It will show you that data also. So Kaito, you would like to add something? I'm going to stop this simulation now, and it will show us as a two different models, what it was created earlier and what it has created now.
Oh, Ravi. Oh, I don't have any comment on this. So yeah, please go ahead.
Okay, so I'm going to stop this simulator. It will going to stop and will say that the model which we were earlier created, it was created in 13 iterations. The first model was created in 13 iterations, and the simulation which we were running the simulation for roughly, I think, 6-7 minutes, 5 minutes. It has done 31 iterations, so it has found actually 31 batches of data files, I believe, and for every data batch, it is trying to load and check that in the background. It creates a new model, and the model accuracy and everything is shown here. Yeah, so this is you can check that what is the model, what is the accuracy, which we have tried to showcase as a demo, is basically a certain number of devices as a cooling tower, and then predict their failure rate. We have tried to simulate with a near real-time scenario where data is coming periodically every minute in our demo, and that data keep on loading into the system and models keep on updating itself, and then they predict that what is going to happen based upon the data. So I think we are all set with our demo and this presentation, and I would like to go into two more slides, and then we will actually go with the question answer session. This is my last slide. I will say that the Vertica has been, focusing on new things, and Vertica will be trying to add more algorithms down the line. But at the same time, we are also so much focused that we will be very well integrating these tools with more analytical front-end tools, and we will also be developing user-friendly GUIs within Vertica, so that you can manage those models. You can on the fly, on the click, you can create models, evaluate them, test them. Everything will happen through GUI, as if you see that you are trying to write even a lot of queries to create that, but down the line we would try to make them more even easy through clicks or through GUI. So with this, keeping in this mind, I'm going to stop here, and I'm going into a question answer mode, and I'm going to read some certain comments and questions which we have found, and we'll try to answer one by one. Okay, so the first question is, in the future, will Vertica work alongside innovative technologies like blockchain? Okay, so Yeah, yes, we would definitely be working on those areas, but we cannot do any commitments as a product right now. But yes, we keep on doing innovative things, and and we will definitely be having some sort of connector or some sort of ideas either to work in blockchain and maybe integrating with those things down the line. Okay, the second thing is that can we get videos link for this WebEx? I think Pradeep will work on that side about getting you recorded session or those things which is possible. Can we debug step by step of this machine learning procedure? For example, I may ask you to know you. It's uh, predicting risks as say 20 out of 10,000 towers. Kaito, you would like to answer this? Can we debug step by step for this machine learning procedure? For example, if I may ask you how it's predicting risks as 20 out of 10,000
Yeah.
towers.
Yeah, we can set up the customized iteration value and then also some value and some algorithm for the logistic regression. So if you access to Vertica online help, you can find out some value parameter to customize the machine learning. Yeah.
Okay. Okay. Thanks, Kaito. And another thing is that the question is that how we can how we can find a good quality sample data as a part of data preparation stage. So I would like to answer that Vertica has created a sample function. I mean, I would definitely suggest you if you can see my screen, we have created a function called balance. I think that will help you to understand. Balance has a lot of parameter. Actually, balance is an inbuilt function in Vertica which helps you to prepare the data or balance data or do the sampling. So it has output view, input view, and different balancing methods. So this is a proven function available in Vertica which can give you a good sample. And other than that, there are other functions also which can help you to give that good sample for creating the model. In run statistics, what does reading means over here? Uh, okay, so I hope you mean to say by in run statistics, what does reading means over here? I think Siva is trying to ask that in our model, if you mean to say about this statistics readings. So the readings is basically a table which is having all the, what does reading means it has all the, I will show you the table name actually. One second. I'm trying to show you the table. So readings is a table which is actually correcting asset wise and timestamp wise temperature sensor data. For every variable it is correcting sensor data, and then we are doing a status prediction after reading all this data, whether it is successfully running or it is going to fail or what is the prediction. So I hope I'm able to answer that. What do you mean by readings mean here? Readings is just data set which we are getting from sensors. What are the skill sets required to operate Vertica machine learning? I would suggest that from the skills perspective, you need to know a little bit about machine learning in advance, that what kind of different techniques are available. From Vertica side, everything is SQL. So you just go to documentation. You open that documentation, and in documentation, we have written everything. What are the different functions? How you use them function? How you use these functions? You don't need to require any special programming language because everything will become SQL. Everything is a function in Vertica. So from that perspective, from Vertica side, you would only need to learn these functions, how to operate these functions. But yes, from a data perspective, you need to understand which algorithm is better for you. Based upon the use case, which algorithm you are going to choose. That is the decision which you have to take, whether it will be a logistic one or linear regression one. Oh, Vertica 9 will support additional algorithms, so that information will come within a couple of weeks. Kaito, you have any information? I hope we are getting new algorithms as well. Any idea?
Oh, what is the answer? Sorry. What is the question? Sorry, I couldn't.
Yes, as I said, there are 6 algorithms inbuilt in Vertica. Banu want to know what are the additional algorithms coming in Vertica 9.
Oh, sorry. This time is I don't have answer for the Vertica 9. Sorry. So
Yeah,
with the
Vertica 9 is going to release, and we will have definitely a few more things, but actually we cannot disclose this thing here. But yes, we will have your mail ID and we will let you know. As of now, we cannot say until unless it is actually properly released. Yeah, but we are going to release it soon. Okay, can we set our own iterations value or confidences level while creating models? So this is a question. Can we set our own iterations level?
Yeah. Yes. Yeah. Depend on the algorithm. Yeah, you can set up the customized parameter. So
Okay.
you,
So while creating the model, there are parameters from where we can set that how many iterations it will take, right?
yep. So depend on the algorithm. So yeah, try to find out which other algorithm you would like to use. Then go to help at the at online help. Then you can find out what parameter we can customize.
Okay. So the next question is Vertica supports dimensionally reduction technique, which usually comes under data preparation step. How did you do feature selection? Vertica supports dimensionally reduction technique, which usually comes under preparation step. Uh, how frequently you retain the model? Okay. So this is a different question from Raja. The first question is Vertica supports dimensionally reduction technique, which usually comes under data preparation step. Okay. So dimensionally correction, there is a method inbuilt in Vertica, usually comes under data preparation step. Okay, data preparation, we have actually documented that. Dimensionally corrected method is there. Then there are what I will do is basically, Banu, I will get back to you on that because I have to take more questions. I will definitely get back to you on that. The other question, Kaito, is that how did you do feature selection?
Feature selection. The usually we have the some I forget. We have the balancing function uh, to uh, to focus on the useful data. So we can use that techniques for the feature selection as well. So also, yeah, but I think that the balancing function is good to find out the good quality of data. So yeah, but we have several techniques. So if you would like to achieve specific requirement, our professional team can reply back to you.
Okay. Okay. So we will actually note, we will have all this question and we are trying to answer all as much as here. And if we are not, we will definitely, give that compiled answer. The next question is how frequently you retain the models? How frequently you retain the models?
Yeah, it's
What?
Yeah,
Yeah,
basically
Kaito.
that it depends on the user requirement. If the model is good enough, we don't have to update the model. So, but this cooling demo, we think that we should reiterate the model using the latest data as well. So at that time, we have to recursively process that prediction, that machine learning technique. So that is basically depend on the requirement. Yeah.
Okay. So the next question is that is there any way by which I can uh, choose optimal parameters for a machine learning algorithm, like optimal value for k means algo. How we can choose that optimal value for k?
At this moment, we don't have that friendly automatic function. So we have to work with analytics specific applications such as R Studio or SAS. That kind of platform is helpful to find out optimal parameter. So
But
basically, yep.
yeah, what I'm trying to say is that optimally means you choose a k and then you check whether the model is good or not. Right now, we cannot tell in advance that what will be the k value. Yeah, you can. Vertica is very well integrated with R Studio, so you can create a model in R Studio and it will visualize you, and then you can see that okay, we want more number of okay value is high or low. Accordingly, you can actually choose that. So Vertica and R Studio are very well integrated. You can actually see that clusters over there as well.
Right.
How the next question is how can we schedule machine learning jobs with Vertica? Okay, so machine learning jobs in Vertica, as of now, you will have to write, I mean, your machine learning jobs means you would be creating models and testing as a first cycle, then you deploy that model within your production environment or the test environment. And then accordingly, you can actually um, run them or call them on demand. I mean, every time, whenever you want to predict data, predict values for the new upcoming data, you need to call them. If you want to automate that, we want to automate the process that create a model or something like that, you would have to run some cron or some shell script to schedule that. Vertica, as of today, does not schedule any kind of model creation by its own. You will have to schedule a shell script or a cron job, which will then call a model creation SQL query. The next thing is, can we use multiple alongs algos and create customized algos or use third-party algos inside Vertica? So you can create you can use multiple algos. If you want to actually create your own custom algo and different techniques along with Vertica, we also provide R as a programming interface in Vertica. So if you want to create your own custom algo, then that R and RODBC are also inbuilt in Vertica. So those R programs will be running within Vertica server, but the difference will be that R will be running, your custom will be running on a single node at a time. What Vertica gives as an inbuilt machine learning is the machine learning inside Vertica will be running all parallel. And when you run machine learning along with your customized R program, probably that R model will be running on a single node at a time. So that performance will be different, but yes, we give an option that you can integrate with R. We also have a Spark connector. We also have a Python programming language interface. So if you would like to customize by your own, you can definitely do that. Okay, so the next question is, apart from logistics, can we use XGBoost as an algo? So this is something, Kaito, you have any comment on this? there is a question called XGBoost as a algorithm. Okay, I think Kaito may not be here. So this is something which Raja, I will definitely come back to you. The next question is that does deep learning supports in Vertica? How does deep learning different from
Sorry.
machine?
Oh, sorry.
Yeah.
Ravi, I was muted. Sorry. For the clustering, for the clustering apart from the k-means, what are other algorithm Vertica support, right?
Question is apart from logistics, can we use XGBoost as a algorithm?
Oh, wait, just wait. I need to read that question. Just wait. Oh, curve, multiple algorithm XD. Just wait. Yeah, I need to understand the exactly XD boost. I don't think so. I never see this XD boost. So let me check with R&D people. We are going to support this function. Yep. So later we will follow up this one. Yep.
Okay, thank you. The next question is, does deep learning supported in Vertica? How deep learning differs from machine learning?
Yeah, we had the plan to support the DNN or deep learning algorithm, but I'm not sure deep learning is the best algorithm for the Vertica platform, because deep learning is basically for rich media analytics. So
No, so
yeah, but
deep learning is definitely will be supported in Vertica, but the way, I mean, in the coming releases, we will have like more neural networks kind of supports where you can improve on logistic regressions. Deep learning and machine learning are actually very closely related terms, and this deep learning is basically improving your models using neural network techniques and generally used with the logistic regressions, and will definitely be supported. As of today, we don't have any functions which is especially designed for neural networks, but yes, in the coming releases we will definitely have that thing.
right. Yeah, could be 9.1, because previously
Yeah,
we had the plan to support the deep learning algorithm. So
yeah,
yeah, let me check with product management people. Yeah.
yeah. Can we migrate existing models in Spark directly to Vertica? Is this supported? Okay, so directly you cannot migrate that model into Vertica. You will have to, because in Vertica everything is SQL. However, we have a Spark connector. So if you are running something within a Spark, but you want quick crunching of data or aggregation and finding out different patterns out of the data, so Spark can read from Vertica. So Spark can still have their own algo there, but they can read data or different group by or data preparation within Vertica and then read within Spark and do that. But if you want to migrate Spark model into Vertica, there is a very, everything will be SQL. Probably your code size is reduced from 10 line to 3 to 4 line. But you will have to actually change everything from your Spark, a Scala or something to a SQL based, and everything will be running in Vertica. So there is no direct migration tool sort of, but yes, the code number of lines will definitely reduce. So you will love to migrating from there to Vertica. For clustering apart from k-means, what are the other algorithms will Vertica support? Example given GVM or hierarchical clustering. Okay, so hierarchical clustering is supposed to come. As of today, we support k-means. Kaito, is any option available for hierarchical as of today?
I think I'm not sure this one we are going to support, but currently we don't support GVM and hierarchical clustering, I think. So yeah, this one we need to check our roadmap as well.
So GBM is something which as of today we don't support, and that is definitely will in the roadmap. Can we calculate gap statistics, example giving elbow methods before k-means? Okay, that is something we have to check the gap statistics. Okay, we need to check on that. Does it supports interactive reports? I mean, can I add them into my application? Yes. Yes, so whoever has that, Nancy, yeah, definitely this supports interactive reports, and you can integrate them, that models, the query on top of that models, and you can integrate with your reporting system so that they can get data out of that model. Does Vertica machine learning have capability to detect outliners in data? Yes, we have an outliner function, inbuilt function, which helps you to detect that outliners in Vertica. Yes, we have the function. Can we compare best suitable algorithm for some data set? No, best suitable algorithm for some data set, as I said, that you need to learn a little bit about what algorithm you are going to choose based upon case-to-case basis. And you can create 2-3 models. If you are confused that this model or this kind of technique versus that technique, then you can create 2 models. But my recommendation is that based upon your use case and requirement, you have to first choose what algo you are going to use or machine learning technique you are going to use of the data. Vertica does not suggest that for this data which is the best suited. How are the 6 models developed in Vertica? Can we develop new models by our own using SDK? Yes, you can develop your own models using SDK. We provide Python SDK, we provide R, we provide C++. So you can develop your own models using those programming languages, and those will become function within Vertica. And then you can call those as a function. Does Vertica support data encryption? Yes, Vertica has a capability to does certain level of encryption of a data where certain columns will be visible in encrypted format for certain users that can be controlled. That is true. Can we use Python for Python? Can R use Python for Python? I don't know what is the question. Model development. Yes, you can use Python as a programming language, but the models will be created in Python. Python will be used to read write data from Vertica. But the models which are created in Python will still be there in Python. They will not be imported in Vertica. Okay, XGBoost, I'm skipping that question because we have almost crossed the time. Can we use this platform for doing text mining and sentiment analysis? Yes, that is correct. Vertica has a text mining and sentiment analysis both capability in Vertica. Vertica has inbuilt sentiment analysis engine, which can do is scoring about certain keywords, and it can give a sentiment score whether people are talking positive or negative. Text mining capability in Vertica is there. We have a text index. We can read certain amount of text data, and you can do text searching within that. But that is not an enterprise search kind of thing, but that capability is there. Can we use Vertica machine learning on data located in Hadoop? Yes, that is true. Vertica is a Hadoop reader. It can read data from there, and then you can create models within Vertica. That is true. Does Vertica support graph analytics? So we have a geospatial analysis where we can do geospatial things. The graph analytics is something, is Crypto aware about is the same graph analytics or it is the geospatial one?
Could you say it again? Sorry, I missed out.
The question is, does Vertica support graph analytics?
Yeah. So later, our Vertica team is going to send you the web link, so that will explain how to achieve the graph analytics using Vertica technology. That is a good one. So, and also you can find the article on the internet. If you type the Vertica and graph analytics, you can find out the good articles. So yeah.
Okay. Okay, thanks, Kaito. So I think we had like completed that 4:30 p.m. was our hard stop, and I think the best part of this session was this question answer, and I like that people have raised a lot of questions here, and we will definitely get back to you with all the questions which we have not answered. And we really appreciate for your time, and we really appreciate with all your questions which you have raised. And we would definitely be available we would definitely be available on that. I will show you that. 1 second. You can reach out to us. I would like to show my mail ID here. You can reach out to us any moment, anytime. You can reach out to me in this mail ID, and I will be happy to answer your questions. With this, Pradeep, I would like to thank you all of you for joining today, and we will arrange for that video for the session, and we will also try to reach you with the question which you have answered. And thanks, Kaito, for joining and guiding us on demo and giving us answers for the machine learning, because you have been implementing machine learning with few customers in Japan. That will definitely help here.
Yeah, thank you, everyone. Thank you, Ravi, everyone. Have a nice day.